Hi, welcome to the third video of chapter 10. So by now we should have a pretty good idea of limit, and especially if we are given a graph, we should be able to find what the limit is or if the limit exists. So in the previous video, um, I solved number 5 to number 8 from exercise 10.2, 10-2. In this video, I'll show you guys a couple examples from question number 9 to question number 12. They are type 2. Okay, so let's get started. Alright, so here I have one example here. They want us to find the limit as x approaches -3, and my function is a rational function. My numerator is x squared plus 5x plus 6, and my denominator is -3 minus x. So why don't you guys open up Desmos and see how the graph look like and try to figure out what the limit is as your x approaches -3. So go ahead, do that now please. Pause the video and do it. Alright, so on Desmos I have already put the equation down, x squared 5x 6. So on Desmos I already have that. And denominator is -3 minus x. Make sure you have the equations typed in correctly. Now if you look at the graph, it is actually a straight line. Right? It is actually a straight line. Now, the x that we are interested in, it is -3. So let's go to our graph and look at -3. -3 is here. As you get close to -3, so this is -3 minus with a small minus. But what I'm doing here, this is -3 with a small minus, and it gets close to, seems like it's getting close to 1. If I get from -3 plus, so this is -3 plus, seems like it is going to 1. But let's say when I put -3 in there, I have undefined. So why? Because if you look at my equation, my x, if my x is -3, my denominator becomes 0, so that becomes undefined. This is a similar example to what I showed you guys in class on Monday. Okay, so, but right now, we know that we're just talking about, when we talk about limit, we're talking about approaching. So what's the number that it gets close to? That's my limit. As my x gets close to -3, my y gets close to 1. Right? So if I zoom in even more, it gets closer and closer to 1. And if I do it from the other side, my y value also gets close to 1. So in this case, my limit is 1. But how do I do that algebraically? Alright, how do I do that algebraically? So, because in the previous example where I show you guys the type 1, what we can do is simply substitute the x values into x. But right now we can't, because I'm going to get something over 0. Right? Something over 0. If I substitute this -3 in the x here, I'm going to get something over 0. And that is undefined. So what do I do? Hope you guys know how to factor, because that's how we do it. Now, I can factor the top. X squared plus 5x plus 6. That becomes x plus 2. Sorry about the writing. X plus 2 and x plus 3. Over, I'm going to take out the negative. If I take out the negative, I will have 3 plus x. And 3 plus x and x plus 3 are the same. And then cut them out. That gives me negative x plus 2. And now I can substitute this in there, right? So don't forget the limit in the front. X approaching -3. So this part should go away. This is not good. I'm sure you guys, the proper way of doing it Okay, so I need to factor it. Now this becomes limit of x approaching -3, and I will only have negative x plus 2 now, negative x plus 2. And now because I can simply substitute -3 in my x, because that's not going to give me anything that's undefined, I'm just going to do that. And my final answer will be 1, as what we saw just now from the Desmos graph. Okay, I'll show you guys another example. Alright, so in this case, this example is a little bit trickier because, again, you will need to know how to factor. Okay, so let me just show you guys how this can be done. So the top t plus 3, I'm going to leave that. That's not going to be changed. However, the denominator 9 minus t squared, that can be rewritten as 3 squared minus t squared. So if you have a squared minus b squared, you get a plus b and a minus b. Okay, so this is one of the properties that you guys should remember. So this now becomes limit x approaches -3, t plus 3 on the top, that stays the same, and I will have 3 plus t, and there you should see something special here, 3 minus t. Now t plus 3, 3 plus t, I can cut them up, so I will get limit x approaches -3 and 1 over 3 minus t. Now if I substitute this -3 in there, I won't have a problem. But if I had done that in the beginning, if I had substituted this -3 in the t here, that's going to give me a denominator of 0, which is undefined, right? But now I have factored the stuff and cancel out, cut out the stuff that we can. I have something that's, I can actually substitute the x in there, and my limit is going to be 1 over 6. Okay, 1 over 6. And that's it. Alright, I'll show you guys another video later. The last video will be on type 3. Okay, hope you guys find this video helpful. See ya.